Okay, now we are all seated together. And before jumping into the topic, I would like to give our panelists a chance to introduce yourselves. So your role and your background and your company scope in the ecosystem. So maybe let's start from Gil. Yeah.
Can you hear me? So I'm Golov. I'm responsible for the marketing and business development at Socionext. And Socionext is, you heard Stefan, is a merger of Panasonic and Fujitsu Semiconductor. And we are building custom SoCs, for example, chiplets, also for automotive industry. I'm more than 25 years in the semiconductor industry. I started as an ASIC engineer, 63 patents in semiconductor, and moved to marketing.
Okay, Kirill, please.
Hello, I'm Cyril Laurie, working in FORVIA. FORVIA is a combination of former FORVIA and HELA. I'm in the CTO organization, so in charge of all electronic-related topic. Actually, I got also a background in semiconductor engineering, so I did chips for 20 years, first in the startups and through acquisition up to a big group. I'm also leading the expert group in French SAE over EE architecture and software-defined vehicles. And FORVIA is active in many topics, from park assist solutions, zonal controllers, radar sensors, power electronics. So we are delivering components in one in every two cars in the world, from let's say something that are very far from electronics, exhaust pipes, seats, down to a very core of electronics.
Okay, thank you. Then Adiak.
Adiak Aguilar, Global Safety Manager at Volvo Trucks for the Embedded Platform Factory. We are designing and developing the propulsion system platform for multiple types of propulsion, as well as integrating the real-time operating system with the adaptive AutoSAR and the high-performance compute power of the truck. Been doing safety research for now almost 10 years, active member of SAE, on-road autonomous driving committee, as well as the UL 4600 from the US committee as well. My background is mostly in functional safety engineering, but my experience spans in different industries, coming from computer electronics and now in the automotive industry. Thank you.
Okay, thank you. And then Frank?
Yeah, my name is Frank Kirschgebiller. I started my career in a startup where I worked 7 years on sensor and system technology, and especially on systems engineering and innovations. Then I joined Ford and spent there around 20 years with various roles in E/E architecture, in networks, and I was leading for a decade the global software strategy and processes at Ford. At that part, I was engaged in AutoSAR and the steering committee for 10 years jointly with Michael, at least for a time. So the SDV journey started for me before that word has been created with AutoSAR. The last 6 years, I was with VW, leading the E/E PMT teams, functional safety and compliance. And especially in 2024, I was the project lead on the VW side for the due diligence on Rivian and a new starting point into VW's SDV world. Next to that, I had some engagement in VDA on agile collaboration and cybersecurity. So I came around a bit.
Okay, thank you very much. Actually, I was also working in AutoSAR consortium for many years when I was working at Huawei. Yeah. So, yeah. But anyhow, let's start for the panel questions. So as we already discussed a lot of topics about moving from the domain-based architecture to the zonal-based architecture. And we're also listening a lot about the legacy hurdles. So the question is here now, we love to talk about the legacy in terms of physical weight and wiring harness. But let's challenge that. Is the biggest hurdle actually our legacy data structures? Now the question is, how can a zonal approach act as a necessary data plumbing to feed real-time AI models when our underlying hardware-software decoupling is still being choked by rigid signal-based legacy protocols like CAN bus, FLEX3? So what will be the effects of this? So who wants to start first? Yeah, Frank, please.
Yeah. So if you see the transition from a multi-ECU based and more function-oriented architecture to a domain architecture, you saw the benefits of having less ECUs, but you saw the disadvantage of having Conway's law means that the organizational kind of footprint had a significant domain impact. And at least some domain-oriented vehicles lack efficiency in architecture because they are domain-focused and not full vehicle-centric, and they lack efficiency in communication. We saw that on several examples. So when you move on to an SDV or an AIDV, you need to become more data-centric. You need to ensure that the data quality in the vehicle and from the vehicle to the cloud supports the real needs of AI. So becoming more data-centric, ensuring quality of data, and that means that zonal architecture, which is highly efficient and mainly driven to a certain degree by EDS reductions and harness simplification, needs to be intelligent and not just a gateway kind of structure. It needs to improve the data quality with timestamps, with quality factors, and so on and so forth. So the intelligence or the edge computing in the zonal computes will have a very great role in the transition from an AI-enabled to an AI-centric vehicle.
Okay, thank you very much. And Adiak, do you want to add something?
Not much. I think I agree with most of what you said. I think here the question is also, or part of the answer to expand is when we introduce some architectures, we're also reducing a lot of wiring and complexity. We're not only reducing weight, but having a reduced length in wiring and cables, physical wiring and cables, potentially can also make us reach our targets of having a low latency network communication of our protocols that we are using today. Will the Zone controller alone help us achieve this? I don't think so necessarily, but it is one of the enablers for sure. And I can agree with what you said. Yeah.
Okay, thank you. And Cyril?
I'd like to complement this vision by the fact that moving to AIDV means also that sometimes you want to get rid of edge computing, especially, for instance, in radars. We are moving toward a world model where the AI model wants to be fed with raw data coming from all sensors, all types of sensors, and this drive, let's say, kind of a simplification of the processing towards the radar head, and boost a lot the bit rate of data that will go through zonal modules. So time-sensitive issue will be greatly extended. Speaking of a highly autonomous vehicle, where we see up to 10 radars moving from signal-based, so 10 megabits, up to gigabit each, definitely it will increase the burden of let's say, data centralization. Cameras as well improving in resolution, so bitrate again. It will be, let's say, still tough, economically speaking, to make affordable solution with a lot of data concentration going inside those centralities.
Okay, thank you. And Gil?
So zonal architecture is one piece of the big puzzle, right? We are moving to high-performance compute. We are changing the architecture of the car. So what we want to do is to get the sensors data somehow to one ECU of the high-performance compute, and we want to get rid of the specific standards and protocols. So the zonal controller, basically, it needs to do a couple of things. It needs, first of all, to convert the data from whatever protocol it comes to something more generic. Usually it runs on Ethernet, TSN. We want to actually have data objects there and send them timestamps which come to a central compute. Different software, basically component, can access it, regardless which protocol it is. We have to make sure we keep the service quality. Some of the signals are very sensitive to latency, but that's what we have to do in the zone architecture. The key is a part of the big puzzle.
Yep, totally agree. Thank you. And the explanation from the panelists also reminds me that we have two interesting talks today about PCIe communication as a backbone, and also the I/O aggregation. I think that might be interesting innovations for the future of zonal architecture. What do you think?
Yeah, I mean, we are changing the architecture completely. I mean, just an example, if you think about, I have here an iPhone, and I also have a Samsung phone and Android. If I go on the street and ask the people what is better, people will swear that one is better than the other, I'm sure, and they will explain me why. Because the user interface, they got used to it. But if you look really, from user experience, they are quite the same. If you look under the hood, they are not the same. They are architected completely different. While Apple architected, they build the architecture by themselves, they made the SoC by themselves, they apply the software by themselves, and while the Android-based phones, they use standard SoCs and make some software. So if you look at efficiency from engineering perspective, no one will doubt that iPhone is a more effective. In a way, we can have some KPI to measure it, right? For example, power consumption for some operation. For example, memory bandwidth and memory density. You know the prices of DRAM today. So Apple just managed to architect a system which is much more cost effective. User maybe don't care, but they make a lot of money on its margin. What happened what happened in the data center was the same. You saw NVIDIA all over the world. Now you see inferences data center guys start to design their own SoCs. They control the architecture because they want to get the efficiency in cost, in power, in memory bandwidth. And we actually are making Socionext a lot of world data center chiplets. We started to get requests from fast-moving OEMs to start to build high-performance compute. Also, it's very similar to data center, just all the safety and security, for the same reasons. They want to save costs, remove the power, and have control on the architecture to build a very scalable system. Zonal architecture is part of this big puzzle.
Yep. Okay, thank you, Gil. Any supplement to be added for this question?
Like we said this morning, definitely this trend is also coming into the software. So in order to achieve speed and cost efficiency, a lot of OEM are trying to increase their grip on the software side. But your point of achieving the scale is really crucial, because a lot of historic OEM are struggling to deliver platforms just by following Tesla trend. Tesla is a 4 premium vehicle range. So the lineup is quite easy. They can put the same architecture in all cars, and that's it. Moving to Volkswagen or Stellantis, the burden is not the same. When you spread your car among multiple car lines and multiple brands, the scalability is really key. And this is also the entire topic of this software-defined vehicle trend, is simplifying the architecture to make it, let's say, affordable for everyone.
Okay, thank you. So I think let's move on to the next question. Yeah. So as we currently just building E architectures that simply support AI, meaning we just bought AI onto existing frameworks, or are we truly moving towards AI native? So this is comparison between the AI supported and AI native, where the AI itself dedicates how the data pumping is designed from day one. If we are talking about the latter, what is the fundamental difference in the actual hardware layout? So yeah, please.
From my personal impression, there are two type of events, and one of them needs to be time-related safety critical elements. And for those, I will be really reluctant to say you will ideally would like to have onboard AI to execute on those safety critical elements. And for non-high safety critical elements, perhaps you could use off-board AI. One of the use cases I see more commonly being used is, I talk a little bit on my presentation, is the capturing the telematics data and then having offline processing of the fleet data for optimization purposes. And because this is not timestamp safety critical, then you could most likely deploy an AI model that helps you label these scenarios. The onboard is more or less what we discussed in the E&E. We discussed enabling or facilitating the execution of AI on board, and for that we discussed with AI chiplets. I've been a strong opinionated person that believes that the system on chips as we have today, they have, of course, neural network and machine learning accelerator components to it, but they are not necessarily yet purposely built for a high intensive performance AI architecture or AI models. And I expect that we as a whole industry move towards architecture that is pretty much defined by AI purposely built chiplets.
Okay, thank you. And Frank?
Yeah, I'd like to support that view that the quality of AI support in the chips will improve. The first AI-specific kind of system on chips, like just announced by Rivian, on the market. So there is a lot to come, and that will change the hardware of the vehicle. We spoke already about the data centricity and the way how data flows are newly organized and become more a leading architecture pattern than they have been in the past, where they just served a purpose. Now they have a purpose on their own to feed the AI machines. I think the architecture people will think about, is AI completely centralized in the vehicle, or is it decentralized? Do you have some AI in the edge? Do you have some AI in the cockpit, in the ADAS? So how do you deploy AI in the vehicle will become an architecture question as well, because it will drive the need for hardware and computing power. But I think on top of all of that, there are a few aspects to be considered, like when you would like to make benefits of getting the data from the vehicle, you need to rethink your diagnostics interface to the outer kind of world. In the past, we transferred DTCs, but they are meaningless from an AI perspective, and they are pointless from a service perspective quite often. Vehicles today are too complex for DTCs. Yeah, so you need to manage your hardware that you, in the end, and some do that already, can transfer all data from the vehicle in high fidelity as required. So you need to make the data available. You need to have probably the memory size for shadow mode. Not new. It's done in Teslas for ages. I know that many OEMs are talking about that since ages and do not do that because of costs. AI is not possible without shadow mode learning and gathering data. So I think the benefits of AI will bring new requirements to hardware, which are basically not highly innovative, but needs to be done, and needs to be done, as someone has mentioned before, in the cost frame we have in the vehicle. So it's a question of how to optimize the product.
Okay, thank you. And so we can use the other microphone, please, Leo.
Yeah. So I see it the same way. Basically, everything which is safety critical has to do with the driving. AI needs to be in the car. We cannot rely on connectivity to the cloud. Connectivity is not always available, and also the latency. And AI is just growing in the car, the complete architecture change. What we can do in the cloud, and we see, is things that not related directly to safety, like, for example, voice recognition. We can write such, AI in the cloud theoretically. Everything about improving the algorithm and training the models, we can, upload it to the cloud and do it because it's not necessarily related to the driving. And I agree with what said.
Okay.
And Cyril?
Yeah, I fully agree with what being said. Just also to mention that when making a decision, an architecture decision, so we are cost driven, obviously. And there's a trade-off to make between onboard AI, even for non-safety, let's say, application, because when you move to the cloud, let's say, it's often the case that you don't own the AI infrastructure. You just buy token for let's say, a service provider, and the cost of those tokens is not guaranteed over time, especially for a vehicle lifetime. So there's also a trade-off to make between putting more chip into the core, having more BOM cost at SOP, but ensuring, let's say, a cost stability of your feature over the lifetime of the vehicle. Okay.
As we are already jumping a little bit more into the next question, actually, so I want to push a little bit more. Yeah. We cannot ignore the elephant in the room, the massive rise of generative AI and large language models. This brings us to a massive trade-off between the latency, cost, bandwidth, and safety and security. In your view, how much intelligence should actually reside locally within the vehicle's high-performance computing versus relying on the cloud-based processing of these advanced SDV features? So, I mean, maybe we could give some examples. So, Frank, would you mind?
Yeah, I think we briefly touched the baseline on functional safety, and probably the same applies on Automotive and Cybersecurity, all highly regulated with UNECE regulation. So I think we need to ensure the vehicle is safe under all circumstances, period, which means you can't rely on cloud too much because that's not reliable. You can't rely not on a single shot AI because it's not predictable. You don't have a safety net. So what you need to do is to create a safety net, either with a second AI system being different and completely independent, so no common cause of failures, or having a classical vehicle kind of safety net for functional safety. I think that is an area where no compromise is possible, but where the industry is still a little bit in limbo, because the EU AI Act is declaring some features of the vehicle as safety critical and putting them under special rigor, unfortunately not detailing out what the answer to the challenge is. That's work in progress and still in definition. So there is no perfect answer right now because the norms and standards are evolving. In other areas like infotainment or some more driver convenience features, I think you have more freedom to move the majority of functionality to the cloud, but still keep a level functionality in the vehicle. So if voice control of the vehicle is failing, it's not the end of the game if you have buttons available. But for navigation, if you completely lose your track or your map data and can't really operate the vehicle, you are not really happy and satisfied. So I think for each feature area in the vehicle, you need to find the right balance between what's mandatory to keep the vehicle operational and what's recommended to do in the cloud because you can do it with far higher quality.
Okay, thank you. And Adiak?
Yeah, I completely agree with what you said. If you take Waymo as an example, they are pretty much doing this separation of drive or functionality, and they have some functionality which is not jeopardizing their robotaxis that they use edge cloud compute for improving and doing fleet optimization whatsoever, edge cases and unknown exploration and things like that. Coming from a powertrain perspective, you don't really want to put your powertrain real time on the cloud. And I bring Waymo as an example because even state of the art, as Waymo is today, even then they struggle with latency. So they are the fallback, or they have remote drivers. And the problem is not the remote drivers themselves, even though there's been discussions and very opinionated comments from the safety domain that the operators are located outside of the US. So it's not only a latency issue due to technological limitations, it's also a physical And now, I guess, borderline legal issue, are they actually allowed to drive an American car in the US if they are outside of the US without a US driver's license, right? So I will say eventually we will start getting more and more use cases for edge cloud computing as long as we can start solving the latency issues. But as of today, I don't think this is a 100% reliable solution for all the main areas of the vehicle.
Okay, thank you. And Cyrus?
So yeah, again, quite aligned with the colleagues. So moreover, when we rely on cloud infrastructure, that would mean also that we bring, let's say, all the safety concept onto the cloud. And that's definitely not the case today. So for me, clearly, we not anytime soon I can imagine having a safety feature over the cloud. So it will be embedded in the cars. And like you said, we have safety net. If you think about the Alpha Mayo model from NVIDIA, there is an embedded safety system running alongside the end-to-end model. But embedding a large language model is costly. We speak about 1 billion of parameters, 100 billion of parameters. So it's not always possible, especially for cost, solution, and power consumption. And we see more and more hybrid approach in the infotainment space, where you run locally a small language or medium language model to handle the first level of feature set, and you give you some time and availability to rely on the second level, a bit more intelligent through the cloud. So it's especially, for instance, for voice recognition, voice interaction. So you can always be responsive, get the user intent, and if it's not to operate the window lifter or let's say a local function, then you can rely on the cloud for getting external data, weather, forecast, and whatever. And sometimes maybe connectivity will be an issue, but it will keep, let's say, the user journey, let's say, okay, because it will have, let's say, a nice fallback answer to this answer.
Okay, thank you. And
yeah, just to wrap up, so cloud, we cannot guarantee connectivity all the time. We can't guarantee the latency. Therefore, yeah, we see some applications, LLM, voice recognition, sometimes mapping, navigation, can do the planning as a cloud, send pieces of the map and buffer them in the car. But the real driving, I just don't see it's coming. And I don't see the fast-moving architecture now coming from China and the US going as a process locally, basically. The need to guarantee the service is there available all the time, real time.
Okay, thank you. And as Frank just mentioned, also the AI Act in Europe. So I would also like to extend a little bit. So the cloud-based and the native-based AI systems. So do we have any effects on the AI Act or limitations? And additionally, about the long existing GDPR. Yeah.
I'm really not in all the details. You would need to ask my son. He's a lawyer and he's an expert on the AI Act. And if you would like to talk to him, join the Safetronic later this year. There will be a session on the AI Act. As far as I know, the AI Act starts with some criteria and risk classification, not really distinguishing between where the AI runs in the vehicle or in the cloud, but it's more coming from what is the purpose of AI and what are the risks embedded. And of course, functional safety stuff is clear, but some other things like driver kind of monitoring is under discussion as well as critical, because it's a debate if you measure or check the physical parameters and physical state, that's allowed. If you would check the mental state or something like that, and the kind of threshold of line in between is narrow, you have a complete different rating. So I think the AI Act is more feature and what you do centric and less on the implementation side. But again, I'm not really an expert.
Okay, then thank you very much. Let's move on to the next question. Okay. So
we have one addition to the debate about onboard, offboard. If you're driving a VW, great car, by the way, you have three kind of voice controls available if you have CarPlay. You can use EDA, which is mainly onboard with some cloud connection, and even ChatGPT integrated, which is very reliable, but not the smartest system on the planet. You can have Siri, which is almost available and less smarter than IDA, or you can have ChatGPT native in CarPlay. And if you use that, it feels like a time jump of 10 years. You really feel the complete power of a complete natural kind of language which you can influence. You have responsiveness, intelligence, which is really ways beyond on what you do in the vehicle right now. So if you have the chance, try it. I found it eye-opening.
Okay. Okay, so next question is a little bit higher level onto the marketing and commercial side. Yeah. So let's look at the business strategy, because architecture costs money. We live in an area where AI-driven software completely defines the brand experience. But if every OEM builds everything from scratch, the cost will kill us. So where is the line in the sand? Which specific parts of AI stack must remain proprietary to the OEM to protect the brand DNA, and which layers must be standardized via COVISA or AUTOSAR to prevent our EE architectures from becoming cost-prohibitive sales? So as we both working in AUTOSAR before, so this is also a question, because from the AUTOSAR standardization, they already try to bind the standardization with AI companies and standards. So this might be also very useful for OEMs to save costs, because it's standardized and we don't need to put much money. But from the company level, this might be also not good, because then we lose the competitive. So please.
Yeah, so the super short answer is 15 or more years old. It's saying collaborate on the standards, compete on the implementation. That was an AUTOSAR slogan from the beginning. And I think there is still a lot of wisdom behind, like you explained, the kind of rationale 20 years ago when the first discussions on AUTOSAR started were, can we afford it to do everything individual? Is it better to have a joint platform? And now comes the kind of longer answer, apologize for that. If you look what's happening in the SDV world right now, you see that some of the standards are active. I think classic AUTOSAR is still alive and kicking. Adaptive AUTOSAR, not in the same way, because we probably have been too slow in defining it and probably providing kind of open source solutions. So SCore, Eclipse, other things are popping up right now. So there is a new competition on standard software which is taking place right now, which I really appreciate, because it can be a new room for standards the car industry needs. But on the other hand, what I'm observing in the SDV world is that players like Tesla from the beginning, like Rivian, like Xiaopeng and others, have a notion of saying SDV means everything in-house. We had similar plans with Carriot, saying we do 70% in-house. We are far away from that now. If you think about that approach, it would mean that this conference in 5 years is very empty, because all tier ones are gone, they are dead. Yeah, if we don't keep them in the business. And the second result would be that the competitiveness of the OEMs would be reduced, because I don't believe that a single OEM can be as innovative as an entire industry. So the quality of the products will not be the same. So I'm not in favor of this radical kind of notion, but it's there, and we need to be aware about the attempt to insource more and more. And there are reasons for that. Reasons like, as we spoke about AUTOSAR is it's complex. The configuration of AUTOSAR is slow. So the benefit of having a standard which is acting as a superset, feeding everyone's need, created, to a certain degree, I'd apologize, Michael, a monster in terms of complexity. Yeah. So what the SDV OEMs do, they strip it down. They use similar approaches, but tailor it to their needs, being incompatible to other standards. And from that perspective, I believe that the industry should do more on standardization, call it AUTOSAR Plus, call it whatever the name is. I'm not marketing anything, but I believe that we need to align on the interfaces, like COVISA is suggesting that we need to align on certain hardware interfaces as well to keep the exchangeability in place, and then kind of second element to the question. It's not all about standards and technical interfaces. It's about creating a newer, trustful collaboration framework that you overcome the old game of, I found a problem, is that yours, is that mine? Oh, I need a new spec, I need an RFQ. It can take 6 to 12 months to fix the problem. That's not SDV, that's not China speed, that's old world. To overcome that on top of technical standards and agreements, we need a new collaboration model and practice in the industry. That's the only way to survive in that future.
Okay, thank you very much. Okay, Adiak, do you want to add something from the functional safety point of view?
Yeah, of course. To start with, a lot of things you mentioned now resonates with me coming from an OEM perspective, and I cannot agree more with you with what you said. Standardization of some sort of whatever new marketing term you want to call it, AutoSAR platform. But on top of that, I think today we have heard a few of the challenges, and I want to focus on one that is more on the organizational side, since you talk about on the technology side. And I think we have experience in the last 5 years or more going through several waves of organizational changes, trying to adapt agile ways of working, trying to become faster in software iteration and testing. I believe right now we talk about software-defined vehicles, and I think we need to also start putting some thoughts in, okay, what type of organizational changes do we actually need to reach the speed that we want to get to, and which organizational changes will also attract more talent. Because one of the key points I summarized in my presentation was, this is not only a technology race, this is a talent race. And right now, AI talent it has already boomed, but it's gonna just, it's gonna increase exponentially. And we need to capture that talent as well. And capturing the talent is not only for the main purpose of designing and developing great products, but it's also trying to meet the expectations of our customers. And when they are getting, like Chinese offers of a new brand new EV from China, and the release date is, weeks after the order, while in Europe we are sometimes delaying the orders because we are still fixing software bugs or application issues or whatever it is. The customers will most likely look around and look at other offers which are going to be released to the market faster in calendar time than the European counterparts. So I think customer retention is very important. As you mentioned, standardization for implementation from an OEM perspective, it's also very helpful. We need to reach those speeds, and I think that's one of the key enablers. But I think organization changes, they need to occur fast as well, without obviously disrupting what actually works, but amplifying and just don't optimize what we don't need. So I think we need to start removing stuff and deleting stuff and not optimize. I think as engineers, we tend to over-optimize stuff, which it should just not exist. I think when we do reorganizations, I think we need to just delete parts of the organization that does not contribute to the speed and the quality of the products.
Okay, thank you very much. And
that's really, I would say, the big thing that's focusing back on the end customer. Because when we speak about value, for me, it's a user-facing value that means the most. So maybe we lost a bit ourselves in trying to over-optimizing everything, feeling complaint because, I don't know, the paint finish under the seat is not good. No one will ever see it, but I've seen it already in my company. So today, and coming back to the question, how OEM can keep their brand, let's say, signature. For me, the point is really to understand what makes a BMW different from a Ford. So, and it needs to be something that is seen, touched, felt by the owner, the driver, the user of the car. So for me, the key focus and something where the Chinese were very, very strong is focusing on the end user and not trying to compete on the rest. So they are also having this ability to share a bit more than we do, let's say with more relaxed rules. So, okay, we are trying to assemble together under some open source consortium, because for me it's pointless to spend money, each and every OEM different, killing the tier ones in the process, just for the sake of it. But really thinking, for instance, okay, I will buy a huge AI model. It's not mine because I'm not a superscaler, so I can't afford to do it myself. How I will fine-tune it to make it sound BMW-like, or Volkswagen-like, or Ford-like, or Renault-like. For me, that would be focusing on the fine-tuning, on the model, on the voice of the interaction, on the language it uses, just to give this, I don't know, Renault could be having a kind of a French accent just for the sake of it. For me, that's really here where the real value will be and will make people choosing these brands against another.
Okay, thank you.
So we all want to make money. I mean, the brands, they want to build cheap, fast time to market, scalability. They can, scale across models. Look at China, excellent cars, high-end, also user interface, AI, 1.5 years. Every 1.5 years comes a car out of the market. It's not expensive. It's technology leading and so on. So, I mean, you just could see the slides today and some of the presentation. The entire architecture has been changed. They control the architecture, they design their own chips, they design their own software. What I agree with my colleagues here, everything what to do with infrastructure, bringing the data to the high performance compute, there is no competitive advantage there. So it makes a lot of sense to stick to standards. But the architecture, everyone will benefit if we do it smarter and control. Another thing, what I've seen in the industry, in some countries, some attempt to do big collaboration between OEM, also we saw in Germany, Tier 1 and OEM, some other part of the world. Usually there is no happy end. It's stuck with some kind of monster, everyone pulls to his direction, nobody moves nowhere. This is also a risk. Again, 1.5 years, car, I mean, this is really an example. They're doing something right.
Yep, totally agree. So standardization is very important. Although Chinese OEMs doesn't do it, so they don't do standardization, which is a pity, I would say. But I don't know whether this is right or not, or wrong. Yeah. So maybe in the future, I would say we can have standardization both in Europe and China. Yeah. Okay. So next we will open our Q&A session. So we are encouraging everyone here to challenge our panelists here. So this is your chance. Yeah, please. Oops.
Yes, so thank you for the contribution already. And the question I have is, we are talking here about AI and the usage of AI. I think the colleague already from Socionext had mentioned the high prices of DRAM. So in my opinion, this will stay the next 5 to 7 years, because if you look at the worldwide capacity of that, this cost will even rise, because if I look at the not only automotive, but also the robotics, there is this humanoid robotics, which have 300 gigabyte of necessary DRAM. So what is your opinion about the cost development of this AI-driven and defined car?
I think the curve of technology has shown us that any new emerging technology at the beginning is very expensive. The volumes are not as high as we would like them to be to justify the scalability of economies. I believe that right now, as you mentioned, the demand is up to the roof, but the supply is not going to get better, as you said, in the next 5 years. I think this is an important factor. Some years ago, I mean, in the industry, we have faced many component shortages across time. We have survived. I think we are looking as well as how can we deploy LLMs with a high amount of parameters, like 7 billion parameters or more, that are not so intense in resources. And if we can achieve that, then eventually you can actually buy cheaper, less powerful DRAM boards and still operate as good as if you would buy the most expensive DRAM. But I think this is part of what we are also looking with, for example, open source LLMs. If you take Llama, you have like multiple modeled versions of Llama, and some are more intense resource DRAM hunger than others. And of course, you can try the ones with lower amount of parameters, and they are not as good yet. My forecast is that we're going to get there, and then we will have less dependencies to hardware resources, hopefully.
So from the one who actually builds the solution and the hardware, just compare, take level 4 example. Okay, let's start like this. If you build level 2, you probably don't want to develop your own SoC. There is no incentive, no reason. If you start to look at the company in the world that move to level 3 at volume, level 4 and robotaxi, nearly all of them design their own high-performance compute for a reason. One of the reasons is resources cost. If you take standard GPU, doesn't matter from whom, it works. There is software, it's easy, out of the box. Somebody mentioned it works. But you pay high penalty. You pay on power, on cost, on DRAM bandwidth, and on DRAM density. When you build your own architecture, and everybody say it's expensive, it doesn't have to be expensive. We are talking to all OEM now in Europe. I'm responsible for Europe. And we start to do the exercise. If I build a very scalable architecture, let's say I take a base die with a minimum for level 1, and I take this die and I don't build a complex chiplet like here, I package it as a single chip. Okay, I put NRE investment for one die and I have a solution. If I have to double the performance, I will take 2 of them. Still, no investment. Maybe I have a very complex sensor aggregation car. I can have another chiplet there that actually will aggregate the sensors and feed these 2 guys. And maybe for the level 3, level 4, I need 500 TOPS. I will build myself an accelerator very efficient in DRAM. How do I build it efficient in DRAM? It's very simple in a way because I know which algorithm I want to use. I can optimize. I can put some SRAM cache lines, reduce. I can do many things. And that's a beauty when we have the flexibility to architect hardware software. I also agree with my colleagues. There are sophisticated LLM and algorithms that are more friendly and safe. This has to be works together. But there is a lot to be done on the hardware side. And in fact, these guys that are moving to the level 3, level 4, level 5, I would say all of them that I know, nearly all of them actually build their own SoC. And if not, they are thinking to build.
Okay. So maybe next question?
Yeah, cool.
Yes.
Another question. So if we disregard autonomous drive AI, so put that aside, because I'm thinking of why do we have HPCs in the vehicle? Why have all this compute in the vehicle? So if we skip the driving part, what else could it be used for? And couldn't we use, cloud services for any other AI purpose in the vehicle, so we don't build up a sort of a technical legacy or too big compute power in the car, which will be old in 2 years, sort of. What is your opinions about this?
Okay.
If understandable.
Who wants to take the question? Okay.
I think one of the leading areas next to ADAS for AI is, of course, everything around driver monitoring and creating nicer environment, a tailorable environment to the driver, like checking his state, the concepts like you check heart rate, you check the temperature, you check everything to accommodate the driver in the best way. I think there's a lot going on, and there are certain safety criteria as well on health monitoring of the driver and so on. That, to me, as it is safety relevant, requires some AI kind of logic in the vehicle, but it's by factors smaller compared to ADAS, so it's not the cost driver. It's an interesting thing, and it's relevant. And I think all the other areas around navigation, around voice, You could keep the basic things in the vehicle, but keep them kind of lightweight and do the full performance AI in the cloud.
Okay. Who else want to add, supplement? No? Okay.
I have two answers for you. The first one is from an engineering wish list, is that you built an ENI architecture which is capable of still being state of the art-ish 10 years from now, which means that you're going to spend a lot of money hardware-wise, and you will still risk that 10 years from now it's going to be deprecated. So it's really not the alternative, right? But that's usually, if you're coming from an engineering background, you will say, yeah, let's just buy the most expensive ECU and yeah, we'll survive 10 years life cycle. And then you realize that's not going to happen in midterm. The second approach I will say is, I do agree with you, like having offline, on cloud offline optimization of certain AI applications that are not necessarily real-time bound or safety critical. I think that comes with less amount of cost and potentially has the highest impact of experience return for the driver. And you mentioned some use cases like health monitoring and driving monitoring. I will just summarize it in driver personalization. It could be entertainment, it could be monitoring, it could be voice assistant or like AI voice prompts, for example. I want to see less ping pong, like with large language models as we have today, like, ChatGPT or Grok, that you put a prompt in and then you get a response back and then you put another prompt in. And, I think some of the use cases or features I would like to see in the new, future generation of cars is having more of a generative AI assistant, where you can actually have a, natural language discussion, like similarly to what you have in some of, if you take some generative AI like Claude or whatever, right? Something like that, I think will boost even more the return of the user experience. And I think we're heading in all domains to that direction. I mean, I believe most of us in the room, we're using some form of generative AI. I actually improved my presentation from before using Claude code. I did it first manually, and the file had some issues when I presented this presentation in Frankfurt a few weeks ago. And then I fixed all of that using Claude. So I think eventually we're going to get there, and it's not going to be just a driver-oriented AI application or solutions. I think it's going to be just a mobility AI solution for all passengers. So you could be sitting in the you're coming from trucks, so it's a little bit difficult to tailor the answer to you. But for passenger vehicles, if you're sitting in the back seat, you still want to have access, I believe, to some sort of independent infotainment, or you want to have access to the generative AI for whatever it is. Similarly, to have, I've seen some Chinese cars, they have projectors in the back seats and screens and things like that, because they are oriented not for the driver, but for the passenger. And I think we need to start thinking along the lines, but introducing generative AI applications.
Okay, thank you. And let's have the last question. Yeah. Okay. Another two, yeah.
So thank you very much for the interesting panel, Michael from Amovio. So Frank, I'm not mad at you. Don't worry. I agree with you. So the thing that when we saw all of this, the evolution of EE architectures, I also had some slides on my talk, and I would like to know your opinion today. A lot of compute is based on microcontrollers, the typical Infineons, NXPs with Cortex-M cores, and now a lot of ARM52 and 53 cores for real-time are coming in. A lot of AI is coming in. How do you see that developing from a percentage perspective over the next year, when we see more central compute architecture compared to today? So will the certain class of compute getting more and more obsolete? Do you have an opinion there?
Yeah.
If I can start, like the first colleague for this morning said, we see a trajectory for every OEM with a different starting point, a different space, and a different end in the trajectory. So for me, all those different parameters means that the global trend will be a consolidation of those individual OEM trajectories. Some will try to concentrate a lot to move with a lot of processing power soon because they want to target level 4 vehicles. Others, like Stellantis, don't. As I even said that level 3 is not for them. So focusing on level 2+, very simple architecture, very entry vehicle, where even today they are questioning themselves on the opportunity to move them on central zonal architecture. If the car is simple enough with very few features, maybe it's not a point to move toward a big zonal ECU there. Scalability comes at a cost on the lower end. So, in my opinion, we will see a gradual shift, but it's very difficult to draw a line saying, okay, end of MCU this year, moving toward central CPU this year with NPU accelerator at this stage. So I think it will be a gradual move. There will be probably some events that will make some bumps. For instance, we are start thinking quite seriously about post-quantum cryptography. So Google make an announcement saying, okay, we see now the shift happening in 29. So in terms of cloud-to-car communication, we need to think seriously how to implement those algorithms. So it will obviously drive a different adoption of processing power because the algorithm won't be the same. So accelerator will change. Maybe it will be more complex. So it's already under discussion at that stage. And maybe we will see another, let's say, ideas. The same Google also published a paper where they show that they are able to compress models to give the same performance with 6-time reduction of parameter on processing. So maybe we will see some breakthrough that will give some disruption in this line. But for me, the road is not that clear.
Kind of simple answer could be more processors and less controllers because we have seen the trend of centralization. But I believe this answer would probably be too simplistic because on all of the graphics I'm seeing, we have now 2, 3, 4 zones and a central compute. It looks like a 5 ECU vehicle. That's just wrong. Because even in the majority of architectures, you have between 50 and 100 other ECUs, secondary ECUs, so you can name them like you want. Start with smart cameras and smart ultrasonic sensors. And the final objective of SDV, of a high integration of the functionality into the zones, is on the way, but has not happened. Yeah, it's a strategy, but it's for the next 5 years. I think we need time to really make that happen. And until it really is there, there's still a high demand for microcontrollers, not shrinking significantly. And what we have to have in mind when we talk about shortages on DRAM, the standard controllers are short in the market to a certain degree, not the high-end silicon on chip system being tailor-made and where you pay for it. So that's a market which is still kind of valid to observe because it's a crunch market.
Okay, thank you very much. And yeah, the gentleman sitting in the background, so please hand over the microphone. Yeah.
Oh, micro.
Oh, okay, sorry. Yeah. Sorry about that. And then we will have 2 questions more. Yeah. Okay.
Thank you. Alexander from Automotive Smart Grid. A couple of times it was mentioned that to control latency, and there's a problem of delays in the architecture, both in this panel and in the previous presentation. My question is, have you thought about using a completely different communication protocol on a base layer for a new architecture?
So you can also dedicate one panelist to answer if you want.
I'm gonna give you like answer that is not necessarily tailored to my experience at Volvo, but rather my experience of analyzing the entire industry. I've seen the trend in some EV startup companies like Tesla, for example, to start utilizing something that they call Etherloop, I believe, and it's been implemented, installed in the Cybertruck. And the whole idea is to have, like, as it is called, an Ethernet high-speed bandwidth communication protocol across the entire Cybertruck to fix the latency issue and have a more flexible network communication for both audio, video, and signal-based as well. But they still rely on legacy communication protocols. They still use CAN for like real-time operating systems. I think there will be impact as we move also with new wireless network communication protocols. We are achieving even lower latencies, for example, for real-time monitoring and telematics. There's a lot of research in introducing 6G as well, because one thing is latency within the car, from the compute to the sensors and actuators. And we discussed today, someone brought it up, timestamps is very important. But then you have also the latency from the car to the cloud infrastructure. And that is what I see the industry moving now in investigating and doing research in 6G connectivity, for example.
Okay. So then the final last question, really the last one, yeah.
Hello, my name is Theo. I'm from ETAS, and I have a question. What do you think about having open source middleware like the Eclipse ESCO Foundation?
I think I like the idea, and I have the impression that the German industry and some other players like the idea as well, because they're interested there and work on that. When you look back to the AUTOSAR discussions 100 years ago, we were talking about AUTOSAR as having open source as well. And for Adaptive, we built a demonstrator which was made available. So that was not a full-blown kind of open source, but went into that direction. At that point in time, we were cautious because some partners built a business on having the middleware and those layers. So that's why it was maybe tricky in the first phase of AUTOSAR. Today, I believe that an open source approach, which is available to many players and where all can contribute, could be one of the answers to creating new standards. So I support it. Still, there's competition. There's Google, they're hard to beat. There is NVIDIA, who just announced to create a Unix being really automotive grade and up to ASIL D, which was a problem of AGL, which never understood that this is relevant. So it is an interesting kind of competition right now, but the idea of open source gives all partners in the industry a chance to contribute and form a standard to their need.
Thank you. And it seems that it's a really strongly supported initiative in Germany, because there was a MOU proposed by the FORVIA that has been signed by, I don't know, more than 20 different companies within Germany and outside Germany as well. So I would add to that having an open source solution, it's also an answer to more and more, I would say, strong regulations from some region. So US banning any Chinese and Russian content in their car, and in China having also a reluctance to use foreign solution. So if you base your middleware on an open standard, an open source, you are also proposing a solution that could be fit for let's say, a world solution. Because today, when you, let's say, many players like tier ones want to address the entire world, and it's difficult for them to move to different platforms for each region. Having China for China, Europe for Europe, US for US is fine, but it's 3 times the fund, 3 times the effort, 3 times the cost. And at the end of the day, that don't help us to make affordable cars. So, but again, open source is something which is not well understood by the automotive industry. So means that many OEMs are still scratching their head, not really understanding the true value. And again, we are back to the value. Where is the value in what we do? And it's not user facing. So what is the point of having a proprietary solution if you're not an expert scaler such as NVIDIA or Google able to afford to spend hundreds of millions on the topic just for the sake of it? It's not within the range of even Volkswagen or Stellantis. So this is why I believe that it's a nice opportunity where I'm a bit, let's say, cautiously optimistic. It's taking a bit of time to be accepted by the entire European industry at the beginning.
Thank you very much.
Okay, so we are running out of time over the schedule, actually. So I would suggest that we give a warm applause to our panelists for the excellent discussion. Yeah? Thank you very much.